Today we're going to go over intercepts of linear equations, specifically lines. So if you've ever had to graph a line, there's a lot of components that make the graph. For example, you could find the points of the line using a table or plugging into the equation. You could use a graphing utility. You could use the intercepts and the slope. There's a lot of different things you've been taught about lines, so let's try to put them all in one place and see how it's useful for finding what are known as the intercepts of a linear equation. So I'm hoping we're all at least familiar with the xy plane, where you usually graph equations of lines or other functions. So when you graph a line, you might have a line that looks something like this. And regardless of how you created that line, let's take a note of some things. Whenever your equation, line or anything else, crosses the y-axis, your point is always of the form 0, comma, the y value in which it crosses the y-axis. So in this case, this would be 0, 2. So that would be known as the y-intercept, 0, 2. Well, wherever it crosses the x-axis is known as its x-intercept. And this point is always of the form, the x-intercept value, x equals -3, 0. So something to note is that the y-intercept is 0, a y-axis value, and then the x-intercept is of the form the x-intercept value, 0. So again, this is known as the y-intercept, and this is known as the x-intercept. So let's go a little further. What if you're given an equation, not a graph, and you're asked to find the intercepts? Let's go and look at that now. So let's say we have to find the intercepts of 4x minus 7y equals -28. I'm going to go ahead and do this by using equation solving. There's other ways to do it, which I'll get to. But first, let's talk about what we just saw previously. All y-intercepts have an x value of 0. So to find the y-intercept, you will set the x value to 0. So I'm going to rewrite my equation. And where the x was, I'm going to put a set of parentheses to show that I'm going to replace the value for x equals 0. So that'll be 4 times 0. And 4 times 0 is 0. So the equation we're left with is -7y equals -28. And that's because 4 times 0 is 0. From here, we would divide both sides by -7. Right? On the left, -7 divided by -7 is 1, so that we have 1y. And that's equal to a -28 divided by -7, which is +4. So if we put all the information we use together, we know that we have an x value of 0, and the y value is 4. Therefore, our y-intercept would be 0, 4. And that's how you find the y-intercept. So now let's find the x-intercept. The x-intercept is a point where the x-coordinate is the x-intercept, but the y-coordinate is at 0. So for the x-intercept, so by having y equal to 0, we can now solve for the x value where this occurs. So I rewrote my equation, and I put a set of parentheses where the y value was to show that it's now -7 times the value I'm going to substitute, which is 0. So a -7 times 0 is still 0. So the equation we're left with, we just have our 4x term, and that equals -28. And we divide both sides by 4. And now we have x equals -7. So to put all the information back together, we can now say that the x-intercept is -7, the x value we found, 0, the value is substituted because we know at the x-intercept your y-coordinate is 0. So we have both of the intercepts. So let me go ahead and pull up a graphing utility just to show that my information is correct so far. Okay, let me type in our original equation. 4x minus 7y equals negative 28. Now, Desmos has this red line for me to look at. I'm going to zoom in on the axes here. And you can see, if I confirm, the y-intercept we found was 0, 4, which is right there on my screen at 0, 4. It's crossing the y-axis. And let's confirm our x-intercept. We found that the x-intercept was negative 7, 0, and there you have it. Negative 7, 0 is the point at which this red line crosses the x-axis. So there's one way to find the intercepts of a line. Let's look at another way. So let's say you still have the same equation, 4x minus 7y equals negative 28. Well, this isn't written in a form known as slope-intercept form. This is known as standard form. So we can rewrite the equation so that it has a more familiar form, which again, a lot of teachers starting around middle school, when you start being introduced to lines, you've probably seen this form. So let me remind you what that form looks like. So slope-intercept form is a form of a line where we write y, the y variable, equals m, the slope of a line, times x plus b, which is the y-intercept value. Okay, so how are we going to do this? Well, if you notice, the main feature of this equation is instead of the equation having x and y terms together and a constant like negative 28 on its own side of the equation, your main goal is to get the y variable isolated on its own side of the equation, and then the rest of the terms on the other side would be of this form. You would have an x term and a constant term. And I'm going to go ahead and start solving for the y term first. So to start solving for the y term, we're going to move the x term away from the same side of that y term. So to get rid of a 4x term, we're going to subtract both sides of the equation by a 4x term. 4x minus 4x is 0, so no more x terms on the left. We have a negative 7y term. And now we can't combine a negative 28 and a negative 4x. You can't combine variable terms with constant terms. So I'm going to put the variable term first, negative 4x, and then minus 28. Next step is to divide whatever factor is multiplying your y variable, which is a negative 7. So I'm going to divide my left side by negative 7 and the right expression by negative 7. And negative 7 divided by negative 7 is 1, so we have 1y. And I know the right side might look a little scary, but just remember that when you divide multiple terms by a single factor, you divide each term by that factor. So what do I mean by that? We're actually going to have two division problems here. We're going to divide negative 4x divided by negative 7. And then our second term is going to be negative 28, also being divided by that negative 7. So let's start with negative 28 divided by negative 7. Negative 28 divided by negative 7 is a positive 4. So my equation is going to have a constant term of plus 4. And then I'm going to take my negative 4x term that's being divided by the negative 7 and rewrite that. Now, 4 and 7 don't divide nicely, so we still have a fraction. So negative 4 over negative 7 makes a positive fraction of 4/7. And that is still a factor of the x term. So my new equation would be y equals 4/7 x plus 4. So we can graph this equation. If you're used to graphing lines, you can actually look at the graph of your line to determine the same intercepts we just found. Hopefully you have a nice equation that lands your line on the x and y axis very nicely so you can actually see and find those points without struggling or looking for a decimal value. So I have my x and my y axis. Okay, so in slope-intercept form, we know that the plus 4 here, this represents the value of the y-intercept. So on my y-axis, I'm going to go to positive 4. So 1, 2, 3, 4. 0, 4 is for sure my y-intercept. Now, this form does not give me my x-intercept, but it does give me the slope. So what I can do with the slope is I can use my slope to find the next point that I would graph on this line. 4/7 as the slope. We interpret this by looking at what's called our change in y over our change in x. Some call it rise over run. What's really happening is we're looking at how much you change in the y-axis or in your y-coordinate and how much you change in your x-coordinate to get to your next point. So one way to think about this is your delta y, so your change in y, and your change in x. So from my 0, 4 point, I'm going to travel 4 units on the y-axis, positive, and 7 units on the x-axis, positive. So they're both positive, so we're traveling up and right. So from this point, I'm going to go up 4, 1, 2, 3, 4, and over 7, 1, 2, 3, 4, 5, 6, 7. So we're somewhere way over here. Now you might be thinking, well, we're getting really far away from the x-axis, which is true. So if I keep continuing this line, I'm not going to be able to find my x-axis, my x-intercept very well. So something else we can do is instead of continuing in the positive direction, we can reverse our slope. So instead of going up 4, right 7, I can actually go down 4 and left 7 to continue the same pattern. I'm going to go down 4, 1, 2, 3, 4, and left 7. 1, 2, 3, 4, 5, 6, 7, right there. If this were on paper, you could use a straight edge. I'm just going to go ahead and graph using my pen here. So here I go. And look at that line, right? And you can see that my line lines up to all the points I found, right? The slope as I went up 4 and over 7 still lines up with the other point where I went down 4 and left 7. And we can confirm similarly that the x-intercept lands at a value of -7, 0. So if you prefer graphing, this could be one way you could find your intercepts. However, this method only works really well if your graph has nice x and y intercept values. So you would have to determine on your own which method you prefer. And depending on the equation you're given, you might have to use either of the methods we talked about today, either using equations and solving for these intercepts or even graphing. I hope that helps you find x and y intercepts of linear equations. And thanks for watching.